let's build a decision tree together. I want to use the heart disease data. So if you have it in Colab, look it up, search something like heart. I've got this load heart disease data. If you don't have something like that, I will try to provide a link for you. What we're going to go ahead and do is copy this file, save a copy in Drive. That way you have your own. You can always check for links underneath the video. And in this data set, what we do is we like to predict the target column, which is whether someone has a heart disease or not. 0 meaning absence of heart disease, they don't have it. 1 meaning they do. And then what we use to try to predict that is everything else in this data set. So let's go ahead and establish this. So Y, what we're trying to predict is the last column. And so I'll use index location, all rows, all columns, all the way up to and excluding just the last column. What I just said was for the X value, that's everything else. So you take all the rows all the way up to, but excluding the last column. That's establishing X and Y. And then I think it's still nice to show the df.head. And so what we have now here is a heart disease data that is in effect ML ready. And you could call it that. We're going to use it to make a decision tree. So when you press Shift Enter here, the advantage is you've got X and Y already established. And I can also assure you that there are no null values, and these are all numeric columns. Okay, so what we're going to do now is make a decision tree. And recall that the decision tree is going to find different places to split the data to try to successfully predict this outcome. So let's go through the essential steps. Okay, step number 1, we are going to load up the decision tree. Okay, and where do we find it? So from sklearn, that's our machine learning library in Python, and it's actually under .tree. So there are different types of decision trees, okay, different types of tree models, I should say, and one is the decision tree. Okay, and this is critical. See that there's a choice between a classifier and a regressor. And so this is actually the norm in machine learning. So basically, you need to know, well, what about this data set? What kind of a data set do I have? Does it require classification or regression? And the key here is your Y value. It's what you're trying to predict. Well, it's all zeros and ones. It's heart disease or not. That is classification. So we want the decision tree classifier. Okay, next. What we do is initialize our model. And we do that using the standard model equals. And then we're using the decision tree classifier. And so we put that in there with parentheses, okay? And you can see there's that genie it's showing you up here that it's going to use, along with a lot of hyperparameters, which we'll get into some of those later. And next, we're going to fit the model to the data, okay? And we do this model.fit, capital X, lowercase y. So, we're making the match so that the X's, all these other columns can correctly produce the outputs Y. And then we want to see what type of a score we get, right? If we just stop at the fitting, great, we're done, but we don't know if it's a good model or not. And so you always want to score your models. Okay, so those are the 4 steps. These are the steps that we've had already. Let's now do it with a decision tree and see what types of results we get. Okay, so press Shift Enter to run the code. And look at that. You get a 1.0. That means perfect predictions. It got every row correct. This is great. So it seems. We can potentially retire from machine learning as experts. We've got perfect predictions, great decision trees, all done. If only life were so simple. So there's a problem, and it's a big problem. Okay, whenever you get perfect predictions, be wary. Okay, so what is the problem here? Well, it's not something that's easy to articulate, but it's here. It's basically right here. And it has to do also in connection with these lines of code, sort of understanding what is the purpose here of machine learning? Okay, is the purpose to do what I would call curve fitting, which is to make some decision tree that's going to correctly predict all of this data? Okay, that's an important step. Or is it going to be to sort of generalize to new data and make good new predictions? Well, you guys, machine learning is not a mathematical exercise in sort of like, it's just not pure math, okay? The point is to make predictions in the real world. And so there's a potential problem here with scoring it on the data that it was trained on. Okay, what this tells us is that, hey, it figured out a perfect model based on the data that we have. But is it actually going to do well on new data? And I guess more to the point is, how do we really figure this out, right? How do we figure out how it would score sort of on new data? And these are sort of big and very important questions that require sort of going to a new level with our understanding, which is what we're going to do next.